What's up, man? Welcome.
Hey there.
Um, so Dan and I have spent quite a bit of time on the mats, and now we're connecting here today. We'll talk about generative AI. Dan and I have had a quick chat early, and a lot of the really interesting topics that we are excited to hear about and chat. We'll talk about generative AI, training data, some of the philosophy and ethics around it, as well as direction and current tools that are fun and the future of AI in general. I'm really excited. So yeah, welcome, Dan.
Yeah, thanks, Jerry. It's good to be here after rolling with you quite a bit. It's interesting we got so much background together. So yeah, I mean, generative AI has a lot of popularity going on right now, especially once ChatGPT came out. People really started looking into it.
The first time I encountered the term artificial intelligence was when I first read about Ray Kurzweil, and On Intelligence, I think was the name of the book. And he started the book by defining what is intelligence, right? Because if you think about it, what really is intelligence, right? Like what defines it? So for me, that was like, wow. And I think the way he defined it in that book was by saying that intelligence is the ability to predict the future. That was like the short term. And then there's quite a bit of people that have other definitions, right? But if we were to start by looking at that term and breaking it down initially, like how how do you see that generative AI, the term as a whole, and as we look into maybe the pieces around it, like how would you define those and how do you understand them?
Yeah, it's interesting. I've never heard it. I don't know if I've read it quite that way. To predict the future, right? My belief is you learn from the past so you don't make the same mistakes. But in the same way, you see patterns,
Yes.
you see habits, and you learn from that. You can also fine tune these if you're an organization and actually plug your own data into these models and then train it. So there's a couple different ways that you can train it, right? One is you build your own foundational model in conjunction with these large language models. You can take, any one of the models. They have different, whether it has 7 billion parameters. I think the largest. Let's take a look again. What the largest one is that Meta just came out. But you have these models, and then you can add your own personal data, whether it's coming from, large data stores that you have. Like for us, for example, you could take documents that a customer has on S3 if it's specific to the organization, train the model with that data. Now you're going to get more specific data to what they want. So if it's healthcare and they're doing some research, they can get responses for their researchers to understand more specific to the data. But there are, if you think about it, all the actual open source data points there are. You can go, AWS actually has quite a bit of open source data sources that organizations can use. And you can go anywhere. You can go to, I'm not a healthcare person, but you can go to any one of these, let's say you go to NIH or something. They have data that they share openly in the public. You can then ingest that into your data model, and then get the output with more specific healthcare data that you actually want. Otherwise, you can see a lot of these models when they're trained, when they end. Because if you say, tell me, anything specific to date, it then will tell you, well, I don't have any data past 2021 or 2022. And until you fresh that data or you retrain the model, you're really not going to see any of that fresher data that comes in.
I go about training a model that could answer me a number of questions for all of my hundreds of thousands of customers, right? All I have now is a bucket with a lot of files, maybe some emails too, right? I can use the email conversations and I can use some PDF with interactions. How would I go about training a model to answer questions based on that data?
Yeah. So there's a couple different ways. It depends how the data comes, right? You've got your base models. Let's say, for example, you take, since we're talking about AWS and Amazon, you take a Titan model, and Titan has its own preset number of parameters that it has built, and now you want to add your own. There's actually two ways you can do it. You can actually rebuild a foundational model, which actually you have to take it, you have to retrain it. And we have services and we have, compute instances like our Trainium instances that help actually train those. but it takes, compute power to actually do that. You also have the capability to do retrieval augmented generation. So you'll hear people talk about RAG, generation with foundational models, where you can take your data set, you take the foundational model, instead of retraining the whole foundational model, you use your data and you build your own vector database with it, or you store your own vectors, right? Because when you create a model, all you're doing is actually creating vectors. So, for example, if you have the word house and you have the word cabin, they might be close to each other. And with those, if you say, I'm going to build a house in the woods, it would come out and say cabin. Now let's actually add in something that's specific. So if you have S3 data and you said like PDFs or anything that you need, you would have to pull the data out that you're going to create the vectors on. And that's where you start pulling in other AWS services like TextTrack. If you're going through documents and it's all text, you can use TextTrack, which is going to take a look and see, maybe a clinician just says, when was the last time this X-ray machine was serviced? And you can put any data in, but you put it in the English language, and then you get a response back instead of having to go to a database and look it up. So that's the scenarios where you use a bunch of other solutions to actually load in that vector database. Now, you can continue to build on, these, retrieval augmented generation models and actually build your vector database, or you eventually can go ahead and build, a new foundational model. If you have enough data, you might want to build a new foundational model, makes it easier to work off of, versus just now growing, storing it in other locations to actually augment the generation. So there's a lot of different ways to set it up.
And is that the most costly piece of getting, let's say we're getting reusing a foundational model or retraining an existing one, is the most costly piece that initial training, or where's the bottleneck?
It depends, and I don't know exactly where all the costs break down. So, but some of the basic ones are, if you're using a third-party model, obviously there's costs associated to leveraging that. Then there's the number of queries against the model. A lot of this is based on the number of queries against it. So that's also a cost that's factored in. Let's say you do 10,000 queries a day, or more. Those are types of costs that will add to the growth. But then training the model usually happens once. Training the model is something that you're going through. It might run, depending how large and how many, billions of parameters you have, that could run a while. And the last part is, the hardware. You should say that a lot of what we call the inferences are created from, right? So we talked a little bit about some of the solutions from AWS. We've got, Trainium, the Trainium hardware, part of our EC2 compute that helps with the training. There's also the Inferentia chips as well that helps with the inferences, so that you actually have purpose-built, compute to help with the inference models as well.
What's been happening around there? What are some exciting pieces of that work that you really enjoy that you can share with us?
Yeah. So a lot of my work actually sits at the database level of the side, the database and analytics. So we're talking about the key databases, data warehousing, that, most of the, transaction processing that customers work on. So, my background, worked for a lot of different database organizations, worked for Sybase, who eventually became SAP. I worked for Oracle. And we always talked about relational databases. That was where my background was. And coming to, I liked about coming to AWS is I could support all database platforms and solutions. In the end, we're providing services for managed databases, managed platforms. So I can find the right service for the right customer use. So if you have a high transaction system, maybe relational databases aren't the best solution anymore. Maybe you need some sort of key value store, or you need some sort of document database or graphing database to help with the processing. So there's a lot of different solutions that you can now take organizations that have been running relational databases for 20, 30 years and actually really make it purpose built, as we call it, to be the right solution for the right application. And that way you're not using just relational databases for everything, because relational databases were the key. I mean, when you looked at databases in the past and you realized what the cost of storage was, what the cost of memory was, everything was, let's rationalize, let's make these relational databases. But they're not the fastest if you need to get a quick query for a, for like some sort of web application. So like we talk about, when I try to explain to people what I do with technical sales, In databases, I try to give them something they use every day, whether they're on the Peloton. So, the Peloton leaderboard, when you're pedaling, that is a DynamoDB key value database that's updating the leaderboard. So you're actually seeing it's refreshing on the screen. It's got to be quick. It's got to be quick things. You're not going to pedal and then see, 5 minutes later, what place did I come in my race. But you think of any of those types of solutions are where technology is being used. And so now having that, now taking that a step forward at AWS, where you've got all this data sitting there that you're leveraging for these, high transaction systems, but now what do you do with that data? Whether you're going to now feed it on into your analytics, you're going to feed it into your data lakes, or you're going to use it to actually help with, some generative AI applications that you have coming forward. Because that's where people wanted to go is, now we've got this data. How do we easily now make it easier for either customers, organizations, civilians to make use of this to, just better everything, whether it's the, service, or whether it's the experience they're having, depending if this is a service organization or, some sort of entertainment type situation. So it's pretty cool. And when you've got the retrieval augmented generation, you build these databases, and you can actually load this into, you can use tools like SageMaker or Bedrock, which is actually now one of our newer, more customer friendly, actually building these foundational models. But you create these extra vector databases that can be pulled in and used to reference when you're actually creating outputs. So let's say, for example, you're keeping track of all the work orders that's been done. Let's say, let's just use something like a hospital, since you use healthcare. And as a user, you've been scanning that all into the reference database or the vector database that is pulled in. And maybe a clinician just says, when was the last time this X-ray machine was serviced? And you can put any data in, but you put it in the English language, and then you get a response back instead of having to go to a database and look it up. So that's the scenarios where you use a bunch of other solutions to actually load in that vector database. Now, you can continue to build on these retrieval augmented generation models and actually build your vector database, or you eventually can go ahead and build a new foundational model. If you have enough data, you might want to build a new foundational model. Makes it easier to work off of, versus just now growing, storing it in other locations to actually augment the generation. So there's a lot of different ways to set it up.
That's a little bit of my background as well. So when I started, it was basically mostly just relational, right?
Yeah.
When I started writing code, and then key value pairs, and then document databases, and graph databases, and vector databases. I've not had a lot of exposure to vector databases, and I know they're used for training models, right? They're used to feed in data over. That's something that I'm still looking to learn, and there might be other database types that I didn't come up with, but I think that's the main. Those are the main ones, right?
Those are the main ones, right? And they spin off from there, right? So if we think about, if I try and, the purpose-built databases we talk about, there's relational databases. We named off a few of the others. There's, what we call a ledger database, which is sort of an immutable database. So if you don't have to do
blockchain is a ledger
blockchain,
database, right?
But it's actually a more easier to use blockchain database where it keeps track of everything. There's time series databases. So if you have a lot of time, especially for a lot of IoT, it's essentially it's using the time series as the main component to average over time and do the reporting on. So any IoT data, whether you're getting data from devices out in the field or in situations, some organizations say you're making like digital twins of engines. How is this engine running every time it goes up and comes down? Is it seeing any variations? And can we look at data that says after we start seeing certain vibrations, we need to get this serviced? So time series databases are very key. The graph databases are very cool. I've seen a lot of, when we talk about graph databases, it's more like relationship. So graph databases, for example, if you go to Amazon.com and you click that you need to get, for example, I just bought a wire that I need to hang in my garage, and it says these are other options that people purchase as well, whether it's clippings to attach it to a wall or something. But that's where it understands a relationship. So like customer 360 situations or fraud detection, for example. And, when you say customer 360, it could be any person 360. So there's a there's a case study out there that talks about how long it would take if it was an organization, a policing organization, where if there was a child missing, understanding all the connections to that person and how fast they could find, if they knew any relationships to someone that might have been involved, finding the next level down. So being able to quickly understand the relationships in that organization, where this isn't, it's not a customer, it's a person 360,
Right.
to quickly be able to find the child faster. So, you get to see, we talk about a lot of times the consumer aspect. I actually cover a lot more of the federal and the civilian side. And so seeing how all of that's built in to help with safety, security, is very cool to see those databases in use.
That's really cool, because in the past, when I think of graph databases, I mostly think of those relationship between products, purchases, right? Social networks, and but the more impactful aspect of it, right? Like rescuing someone, or actually, maybe finding and addressing criminal issues, right, or things like that. That's actually a really cool aspect of it, perhaps not talked about enough.
Mm-hmm.
So if I go back to vector databases, did those emerge with this effort and are maturing together with the models that are trained? And what's the background there?
So a vector database isn't in and of itself a different database. It's keeping vectors in a database. So for example, if you look at if you look at, say, Postgres, or we have Aurora Postgres, we have there's a module that allows you to track vectors. So the key thing about a vector database, when I say a vector database, it's really storing this one in a relational database. You can also store vectors in OpenSearch, so more flat file type data. But I say a database because as you get more vectors in there, there are some key indexes that you'll build on the vectors so that it's easier, I won't say easier, but faster to get to the vector comparison that you need, right? So like I said, depending on how many parameters you have in there and you create a vector, like literally for every word, you create a vector. So if your document says, the last service time for this sonar machine was, each one has a vector. Each word is translated into a value, put in the database. And then any of the values that have a closer relationship, the vectors are different. It's just like seeing a graph. So if you can see me draw, there's some great articles on it that really show the relationship of the number to the closeness of the different words that should be associated. And that's how these modules, these inference modules, end up start building the response that you have. And so the vectors, as I mentioned, when you create the vectors, so when you import or you run through all your PDFs, let's say, for example, you take these PDFs, you run through TextTrack, you actually send it to either SageMaker or Bedrock or some sort of service that's going to allow you to create the vectors, which then actually create the vectors and put it into the database. But when I talk about a database, I'm actually talking, when I think in my head, some of the relational databases that have the vector module in there so that you can use that.
So a vector database also responds to proximity, right? So is it similar enough to a graph database with maybe another dimension to it? Because now it also is responding to that. So through that, it finds it gets better over time because the proximity gets more confident, right, or less confident. So you're improving on that. So is that one of the aspects of vector databases?
I would say a little bit, right? The vector model, right? Understanding a graph database, the way it pulls data in, doesn't go through some of the different, when you're actually building a response or you're actually loading a vector in, it actually goes through a couple iterations to fine tune and create the best output. Whereas a graph database, it makes sense from the sense that, it is sort of the relationship with the data and understanding how it's related. But the vector database, when you actually train a model or even actually do the inference and actually creating it, goes through a lot of extra steps of how it's actually building that comment. So that's a little different than that. So I've never tried to compare it to a graph database. So it's an interesting scenario. Something I'll have to take a look at.
That's something I want to study more of is vector databases, because it's one of the databases I have not played with, and it just sounds a lot of fun
Yeah.
to be able to prepare and really just understand understand it better. For someone looking to really also get into generative AI, I think understanding what a vector database is and what it does would be helpful. So I'm excited to start looking into that soon here going forward. With that, with the complexities and the benefits of creating a new, creating or training a new model, Dan, what do you see as some of the more exciting products and tools that are out there?
I mean, when it comes to generative AI, right, you're taking a look at the different models out there to work and build upon. So, each organization is creating their own models, and you got to take a look at what the models do, because there's a lot of stuff that you want to do, whether it's text generation, whether it's image generation, music generation. I mean, any of that can come into play. And so, was the model built to actually create that? So you got to make sure you have the right model built for what you want to do. The great thing about as I was going through and learning that, you understand ChatGPT, you've got Meta, you've got a lot of ones like AI 21 Labs. There's a lot of different models that different organizations will say work better in different scenarios. And the cool thing about Amazon Bedrock, which was actually released, is you have the option to pick from all those models, and you can run from them, as well as using Amazon's or AWS's Titan model. And there's even one of the cool things is actually we have a partnership with them, but Anthropic, which is a AI model. So Anthropic's really meant to make sure, hey, let's make sure as we're pulling in models, we're eliminating things that shouldn't be in there, whether it's bad words, whether it's anything that could be child friendly. But even thinking about when you're building models that will be good in that scenario. So I think that's cool. So taking a look at all the different tools out there, and all the services that you need to build them together. I think that's the biggest thing, especially as you're starting to look at how do you actually build these models, what's out there, how can you easily incorporate it with your current data. And a lot of that is just having it all in the same place, right? So building it from the ground up, whether your data is already in AWS, whether you're moving data into AWS, how you're training these models. So, the technology is all there now. And before, where you had to know a lot of really deep technical information on TensorFlow and PyTorch, and trust me, I don't know those things at all. I just know the words, so I sound smart. But you had to build your own, AI and build your own capabilities. But now this is built into tools out there which make it more point and click, so that these models can be built, just like databases in the past. I think I was telling you earlier. I mean, when I started the database, getting a database up and running and then learning how to put data in there, took weeks. You had to get hardware, and all that stuff is right there. The services are built so that you can get that work done and really focus on your business or your organization. So Bedrock is actually very cool. Being able to take a look at how that works, there'll be a lot of growth in how that comes out as well.
Can you tell us a little bit more about Bedrock for someone that hasn't used it and is looking into it?
The idea behind Bedrock is to help build sort of the generative AI application from like a single point. When you think about how you used to build AI models, in the past, like I mentioned, you had to know, you had to code in PyTorch, TensorFlow, be able to create these different models that you wanted. Now with Bedrock, it integrates a couple different components that we've been talking about. There's the foundational models that get built. You pick the right foundational model. You have that in hand. You can either decide to train it or leverage what you have. But then the integration with the backend, right? So when you look at different AI solutions, so let's say, for example, we talked about TextTrack. TextTrack is an AI solution. We've already trained it, or we've created the capability to go through and look through documents and find text out of it and understand the text, and it can learn, it can understand, certain changes to text and subtleties. So that's what we consider already customer friendly sort of AI solution, as opposed to being built all the way down at the bottom stack, which is writing code and PI or PyTorch or TensorFlow. Sort of the middle level is SageMaker. So SageMaker is one of our key tools that allows you to do it quite a bit in terms of creating these machine learning models. and allows you to integrate with a lot of solutions out there. So our databases have SageMaker built in. A lot of different features have SageMaker built in. So it's sort of the middle ground of creating some of these code bases and creating effective customer applications. Now Bedrock integrates with that, because with SageMaker you have to then build new models. But you can also point it to your data. So since you're using Bedrock, having it in one place, you can point it to your S3 buckets. You can point to where your data is coming from, and also either train the data or create, like I mentioned, that retrieval augmented generation, and have those vectors created. So in a single place you can go to Bedrock and get all those components where you don't have to understand. Cool. Let's set up S3, let's set up SageMaker, let's set up TextRack, let's extract these data. It's built into a single user-friendly interface that will allow customers to sort of easily create these customized generative AI applications.
Okay, that sounds really cool. I haven't used Bedrock myself. It's also new.
Yeah, just went GA.
That's another service I want to definitely take a look at.
I mean, if you take a look, Bedrock is there to help build Gen AI applications. But you take a look at what AWS has been doing around AI and ML, and just a lot of the pre-built applications to help organizations. Whether it's we've got different tools out there like Poly recognition, TextRack, everything to help understand images, understand voice, change text to voice. So things that can be leveraged in any business, whether it's call centers, whether it's help desk, things of those nature. So there is quite a bit of AI solutions already out there pre-built. Bedrock is really meant to be, the next generation for building these generative AI applications that will build on top of that. And we'll use some of these other features as they get added in.
Well, that's a good segue into something I've looked into briefly, and there are a nearly unlimited number of those out there. 99% are probably just no good, right? They're just someone having fun or have no product. But how long until the models that are trained with historical stock market data, are just overwhelming, so that a person with lower resources just can't compete? They just have to stick with basically outsourcing their investment, right? Because where can you get more accurate and well categorized data than stock market data, right? That's very well available and publicly available too.
Yeah, I think you're using a scenario that is based, you could easily argue the stock market is not built on data per se. It's built on emotion. It
sure is. I would definitely argue for that.
You would have to build, right? So this is where you just get into the analytic part of it. Yeah. Obviously a lot of these brokers and stuff take a look for patterns, right? They look for double dips, they look for teacups. That you could actually take a look and see, all right, let's plug this in the model. A lot of models already have those built in. Those are very simple things to look at, right? If you wanted to build it even more, then the question is, do you incorporate it into weather data? Do you find patterns that, Diamondbacks go to the World Series, and now we're going to buy more Rawlings bats, and so the Rawlings, whatever, something crazy. I had to throw a pitch in for the Diamondbacks, but that is the question of data. And like you said, is it a true predictor of the future? I think once you start getting that, just like any data, data gets gamed, data gets changed. You got to understand the bias of the data that's underneath it, how it was collected, and what time it was collected. So, that'll be interesting. I don't know.
Yeah, I imagine that we have J.P. Morgan, Chase, Wells Fargo investing a lot of money to try to figure out how to do a decent prediction on that, and I don't think that's going to stop. Right? It's always been that way, and probably continue. I do have one sentence I've heard about the description of the stock market, and it's one of my favorite. It's the stock market is a reflection of rich people's feelings. Depending how the feelings go, that's where the money's flowing there too, right?
Until Robinhood came out. Right?
Until Robin,
because we just had a movie on that, so that is true. So,
Robinhood, and what was the GameStop instance too was fun to watch. I did not participate, on it, but I do have friends that I have one that made okay money. He didn't make a lot. He got in fairly late, and I have one that lost some. So,
yeah,
but he got in very late.
yeah. I mean, and the big thing, and one thing I wanted to also bring up is we were talking about Bedrock. Actually, one of the other very cool solutions we released was Code Whisperer. So we talk about taking these applications, and that can be integrated to a lot of different development environments. So we talk about the benefit of generative AI, understanding things like patterns, but also making every day what you do easier. For example, developers, which is a great example, you can just type into a block of code, say, generate a routine to query users' data, find all the users that have X, and output it to the screen, and it will create the code for you, whether it's in any of the platforms that are supported like C or Perl or something like that. And so when you asked me earlier about what were some of the other cool tools out there, Code Whisperer is very good.
Code Whisperer.
And as more things get in there, it just makes even IT, and it makes the technology environment so much more open to people as they start to learn. It's not so scary. So that was a cool tool too.
If we look maybe 2 years, and then maybe we look 10 and 30 years, what do you think the impact is in our day-to-day lives? How will it change?
Well, I think anything we do, either it's going to make it faster, cheaper, better, or it's not going to continue to be developed.
Yeah.
Right. So it's going to, I hear lots of commentary about, technology, the lack of people coming into the technology organization. You need tools to help cover those gaps, right? So you're always trying to do that. You're always trying to get solutions out there faster, right? You look at, if everyone has seen some of the stories on, Amazon.com. When Amazon.com was created, it was a big monolithic system. And after a while, the way AWS came to being was they realized they had to find ways to make it more microservices, cut it into pieces, but that takes time, takes development. And then any iterations you do require more code, more changes and understanding. So being able to build that stuff faster, get it to market faster, that's how companies, organizations are going to beat other organizations. So it's going to make competition better, but it's also going to reduce costs for organizations. And in the end, it should provide, as everything, a better experience to the consumer, the civilian, anyone that's using that data, to make life better. So, I like to think of the good in everything. So I think a lot of positive will come out of it.
Yeah. How would someone, maybe they're just finishing high school, they're just graduated with a degree in computer science, or perhaps they're not very happy where they are in their career, someone that's early on, how do you think a person in this situation can take advantage of this technology to evolve as an individual?
Yeah, I think just understanding the basics first, right? Just understanding, a lot of times, if they've gone through a computer science degree, they should have a good understanding of cloud infrastructure these days, right? When I went through it, it was FoxPro databases and real old technology, client server, mainframe. And then you had to learn different client server technologies, networking. Nowadays with cloud infrastructure, it simplifies all that. It makes it easier to manage for sure, but you still have to understand the concepts. So making sure they have a good foundation in the concepts, and the cloud technology makes it a whole lot easier to put it into place, right? So understanding, hey, if I've got to set up firewalls, I've got to set up, VPC, virtual private connections between different systems and protect them. If you have the concepts understood, it's going to be a whole lot easier to put into practice. For example, with the AWS service. So understand the concepts, being analytical into thinking, understanding what the benefits are, and then, learning the technology, I think is fairly easy. Going through, and we talked earlier, like getting a cloud practitioner certification, understanding how regions, how zones work, availability zones, understanding those concepts, then make it a whole lot easier to understand how to plan out applications and how to protect organizations, how to make them resilient, how to make them faster, are the key things. So, yeah.
Yeah, I 100% agree with you on that. And part of my path was similar. And as you know, our company, Magycall.com, does help folks reach and achieve those certifications, right? Complete them, learn which ones they need to achieve the goals that they have, their career goals or their personal goals. And that's been my experience as well is that in-person learning has really helped me in the past, and to me it's a lot more engaging than online. But it also goes by how each person learns, right? So I understand have your own time. There's a lot of advantages to that as well. For me personally, I think that in-person interaction, that camaraderie, like we get in jiu-jitsu as well, brings me back a lot.
Yeah, I was going to use that. I mean, we've been talking this whole time and haven't used any jiu-jitsu correlations, but right, everyone knows, everyone's seen, whether it's UFC or something, they've seen rear naked chokes, they've seen arm bars, but putting it into practice requires hands-on. Requires iterations, understanding the concepts behind it. And then obviously there's a lot of practice that goes into it, but that's just like anything, you get better as you go. And so, having hands-on is key, and also key concepts. So
yeah. I'm really excited about the future. I think that what's coming is fun. I'm like you in the positive aspect of it, right? One could speak to a lot of ethical and unethical paths that this could take. I'm certainly on the positive side. I think there's a lot of the force of good prevails. I definitely feel that the force of good tends to prevail and will continue to prevail. So I'm excited about the future. I'm working with myself and with people around me to learn and also teach where I can. And I'm really looking forward to see where we'll be 5 years from now. I think it will be very distinct already from where we are today and what we do and the way we work.
Yeah, for sure. And it's and from my perspective, and even from everyone's just learning about Gen AI.
Yeah.
They all want to put it into a practical use, but not many people have gotten there yet. A lot of people have a lot of analytics and stuff, but they aren't truly, they haven't truly empowered the Gen AI. So it will be very interesting to see more applications put into place. But a lot of those are already starting, basic help desk, call centers, and things like that. And those are easy places to put it, but and other areas too. So for sure, it's going to be awesome.
Yeah, I'm really excited. Anything else I didn't ask you then that we can talk about and cover?
No.